In the last video I prepared some water jet cut aluminium plates by drilling, countersinking, reaming and tapping out their holes to the correct sizes. In this video I received long MGN12 linear rails and continue with the assembly of my CNC machine. So my longer rails have arrived today as well. Got the 100s and the 65s. This rail is the only unusual one, everything else is pretty consistent. What I'm going to do now is just leave them in some alcohol. All of these have the letter B engraved in them and this one has W, I don't know what that means. This is what the methylated spirit looks like after the rail blocks have been in the solution for about 3 days. I painstakingly check each rail block, replace any lost bearings and placing the blocks on the rails. If I don't think a particular block sounds or feels smooth, I carefully move that block to another rail, picking the best combination. Eventually I got everything working smoothly bar one length. This just to illustrate the problem I'm having with the rail blocks. These are really good. This one, everything is difficult. I bought these from a seller on AliExpress and asked them what they suggest I do, and they suggested trying to seat the block by hammering them. So this rail is not ground properly, it's a bit too thick, so I need a replacement. Instead I actually used a thin piece of diamond abrasive which I drew along the length of the channels that the bearings run along, and this actually improved things. This rail might be a little bit bowed as well, so once it's pressed flat against a bit of aluminium extrusion, should be a lot better. Not as good as the other rail. I did try whacking some as well, but that didn't seem to make much of a difference. It is clear some run better than others, but the range is quite narrow. I think what I'll do is put the best moving rails on the thick section of each plate and the slightly coarser sounding rails on the section with the slotted holes. I'm now making the spindle mount. To save time and material, I'm going to do this by cutting the outer shape first. This is a 170mm square, which I do on the table saw. I then make a cradle to hold them on the CNC machine, which I use to mill the clamping hole. I made the cradle slightly undersized and slowly resized the hole until I got a tight fit. I'm using 16mm Acetal, which is an engineering plastic and a really nice material to work with on a CNC machine. I then cut the opening for the spindle, making sure to use tabs and bridges to hold the offcut in place. After which I took the offcut out and made a second pass while the piece was still in the cradle to mill the bridges away. I checked the fit of the first piece on the 3D printed mock-up, and being happy with it I decided to cut the second section out as well. I then marked, drilled and tapped all the holes on the spindle plates. The ones at the rear will be for fixing the plates to the Z-axis plate, and there's also the clamping mechanism at the front. I use a bed vise to hold the material in the right position, and also a piece of 6mm ply to stop the material squashing and changing shape while drilling. I drill the holes out with a 4.2mm stub drill bit and thread the opening with an M5 tap. I assemble and check things as I go along. For the clamping thread I first had to drill an opening a little wider than the shaft of the tapping bit, and I've done this through the clamping section. I spot marked the main body of the clamp with the large drill bit. You can see I used a bit of 6mm sheet material to stop the clamping section from flexing while drilling, and then swapped over to a 4.2mm bit to make the hole before tapping.
What I'm going to do now is just cut the ends of the rails down. I've got a piece of C-beam here that's just shy of 30 centimeters.
I don't want to have to buy another rail or cut a larger spare piece down, so this will have to do. If I'm careful, I shouldn't ruin the rail too much. I then began setting the first rail the correct distance from the edge of the C-beam, and using the dial gauge jig to set up the second rail. I explained how this works in a previous video, so I'll brush over this.
So it's about 0.03, 0.02 between the rails.
I'm using stainless steel machine screws here, but later I swapped over to high tensile ones. I then fixed one side of the rail blocks to the plate using 8mm machine screws, followed by 10mm machine screws with a washer on the opposite side. One side is fixed securely while the other, the longer machine screws, bottoms out in the threaded holes and allows for a little flexibility in the movement. I'm now cutting the standoffs for the nut blocks. I had to surface the acetal down to 10mm and then cut the shapes out. I'm cutting a few more than I would need in case I build another machine in the future. I measure from the top of the material each time, but I could in theory measure from the wasteboard upwards. But what I've noticed with bead...
Just went to make a cup of tea and the thing just kicked itself off. So I should have really put some more tabs there. Okay, I got another two and then I had to just stop it. Starting to sound a bit funny here, sort of crunching sound as it was plunging down, and I can't tell if that's something else breaking. That was the last job I was planning to do with this CNC machine as it is. The clamping plates are starting to crack and I've got all the parts ready for the new version of the machine, and these pieces here that I just cut are the standoffs for the nut blocks. Time to die. So the last thing I need to do is to drill a hole through this nut block. I've actually fitted some on already and simply held it in place and put the machine screws through. What I need to do now is tap the nut block, so I've marked the center of the hole and where that lines up with that.
I use a parallel punch held in the bearings at 90 degrees to the plate, knocking it with a hammer to make a mark on the blank nut block, and then drill a 7mm opening and use a TR8 tack that I made some time ago to make the thread. I decided to make my own tap because I've noticed that there are slight variations depending where you buy the lead screw and blocks from. Some just don't fit at all despite being listed as compatible. This is because some threads are square while others are rounded. Even some lead screws and nut blocks sold from reputable places can be quite difficult to thread, so for the best result I found making my own was the solution. I also drilled a smaller opening for a M5 thread which accepts a grub screw to tension the nut block. When this is in position, I will also add a nut to lock it off in the correct position. So make sure if you're going in from the bottom, you've got the washer in, then your locking collar, loosening the tensioning grub screw. It's hard to see, but make sure the grub screw is extended out a fair bit because you may need to push the tab in while you're putting the lead screw through the threaded hole. If it's not in the right position, it can actually pull the smaller section that has a thread on it away from the main body,
and actually tension it before you have a chance to actually use that grub screw and that locking nut to add tension. So you should be able to twist it in by hand. Locking collar, washer. Okay, that feels really solid. So just place the hard stops in position. Somehow overlooked it, but this is really close to that. So the distance between the back of the plate and the face of the aluminium extrusion that faces the plate is 13 mil, and that's correct. So the error is in the acetal plates that I cut.
No, the error is in me having reduced the thickness of the plate, but not doing so in the 3D model or compensating with the positioning of the spindle opening. As we get closer to the end of this video, I'll share more of my cock-ups.
So that's even more reason to be pleased that I didn't cut these or try and make these in aluminium. In future, what I could do is just add a kind of curvature along the face of this curve here and at the rear. They're both identical, and that will create enough room for the spindle to pass. So the rails are a couple mil longer again, and I'm not going to buy another length of aluminium extrusion, so I'm just going to cut these down with the angle grinder. Just put all the T-nuts on. So I've just put the T-nuts and the M3 machine screws in, so this is in position. What I do now is use the same jig on the opposite side to set the first maybe 3 machine screws at the correct distance. It's almost like a hole right in the center would be really useful for setting these. So one problem I think I can foresee is how to attach these limit switches underneath the plate. I don't particularly want to do them now and wire them up because I haven't really thought about that stage. I then decided to try and rehearse the assembly, imagining that this had already been screwed down. I think it's going to be really tricky. I think what I'm going to need is some kind of 1/4 inch ratchet I can get in there and tighten these up when I need to. I don't think it's worth putting these on, wiring these up and putting them on now, because I just don't know how I'm going to do these, whether these are going to be normally open or normally closed. The other thing I've just realised as well, grab a straight edge on one of the squares and push that down on one side. I can see that these are not lining up properly.
carpenters use winding sticks to do a similar thing on boards, and I should have used this method earlier to identify any major twists before assembling a good deal of the machine. What occurred to me, unfortunately after fixing at least 3 of the plates using the slotted holes, was that I should have used a different method, Shims. The plate can pinch and restrict movement when tightened to twisted rail blocks. While I can still move my plates when everything is fully tightened, it's preferable to get things running as optimally as possible so there's less strain on the motor and parts. What I should have done was to check the distance at each threaded hole on the rail blocks with a feeler gauge and a straight edge. Pushing the straight edge down against the unslotted rail blocks, which I use as a reference, and after identifying the gaps with the feeler gauge using some thin 0.2mm shim washers to pack out the gap between the plate and the blocks. Now the twist could be the rails or the rail blocks themselves, but I've also had the experience of receiving aluminium profile that was not square. There's not much you can do with the latter, but the shims would help with the former.
So these sliding nuts will be for the angled bracket. That adds a little bit more support to the Y plates when they're screwed down.
I'm going to jump ahead a little, as I've essentially installed all the rails using the same method as I showed on the Z-axis. In addition to this, I replaced the 3D printed 90-degree brackets under the wasteboard with aluminium ones.
Okay, so I've just noticed something that I need to change in the design, and it's this plate here. The bottom section here that screws into this 2x4cm piece of aluminium extrusion is a little bit shifted to one side, and if this end is in line with that face of the plate, the rail block actually hits into that and it can't go the full extent. So I'm going to have to change the design for the plate, but to get around it I can just use it lined up with this side of the C-beam. Okay, I've just fixed everything together apart from this section here. The 2 support pieces at the front and back are a bit too wide and they're knocking on one of the sides of this, so I'm going to have to measure this, dismantle it and cut it down.
I also had to make a simple tap to further adapt the Y-plate nut blocks to run more smoothly along their threaded rods, but in the end I had this to show for my efforts.
Okay, I've plugged it in. The limit switches are not connected, so obviously I can't home the machine, but I can move it around and it does seem to be working.
I can't home the machine yet as I still haven't installed the limit switches, but it's moving and it's a lot quieter than the previous version. Again, I overlooked some additional things, including not lining up the motor plates properly to the aluminium profile, and there not being enough space for the drag chain to fit along one of the Y-axis C-beams where I intended it to go, and that the X-axis lead screw is so long, if I move to one end, it flexes on the other side. I didn't notice this before in the previous machine because the lead screw was facing away from me, and this will be a problem if I hit the hard stops or work on harder material or cut too quickly. One way I could get around this is to put a locking collar on the outside of the plate, fixing the lead screw on both ends. I could also still install a drag chain where I intended, but this would reduce the overall width of the cutting capacity. So every time I get a step closer to finishing, I realise there's a ton more things I overlooked or new ideas I'd rather follow despite being halfway through realising the previous ones. But hopefully in the next video, which should be the final one, I'll just need to install the drag chains, fit the new limit switches, remove the old proximity sensor wiring from the controller, and then I can actually make something. Fancy that.